Okay, example 4, basically you are rewriting the solution in standard form. So, first thing I need to do is I'm going to pull out, for the square root of negative 8, I'm going to pull out an I and make that square root of 8. And then I'm going to multiply that by, pull out the negative in front of the square root and the negative 6 and make it a square root of 6. From here, just multiply the terms. I have an I squared, but then I multiply everything underneath the square root, so I have 8 times 6. When I do that, I squared gives me negative 1, and I get square root of 48. When you do the square root of 48, I like to do a little factor tree, looking for squares. I get 4 and 12, 2 and 2, 4 and 3, 2 and 2. So here's a prime factorization for 48, but I'm looking for pairs. I have a pair of 2's here, a pair of 2's here. So anything that's a pair gets multiplied to the outside. So I got a negative 1 times a 2 times another 2. And notice this 3 was left over, and so it goes back underneath as a square root of 3. And then combine like terms, or multiply. And I get a negative 4 square root of 3. For b, when I multiply this out, I get a 1 minus square root of negative 14 and a 1 minus square root of negative 14. I'm going to once again pull out the i's. So this is 1 minus I square root of 14 and 1 minus I square root of 14. Foil it out. So the first part I get 1, and I get a minus I square root of 14. For the inside, I get a minus I square root of 14 and a positive I squared and a square root of 14 squared. So everything's being squared when you multiply that last part. And clean it up. From here, I get 1, I get minus 2i square root of 14, because I have 2 of them, just like they're x's. And then over here, I squared is negative 1, so I end up with a negative, and the square cancel, and I'm left with a negative 14. And then 1 minus 14 is negative 13, and then minus 2i square root of 14. And 14 I can't do anything with because it's just 7 and 2, and those are both prime. So there's my final answer.